All right, time for test number 1 out of the blue book, and we're going to do section 8. And this is my, in case you don't know what the blue book is, let me hold it up for closer inspection. This is my poor battered copy of the blue book. And we're going to go, let's see, this test starts on page 419. And after I do this section, we're going to have seen all the math sections out of one of the SAT tests. So, okay, let's see. Number 1, according to the chart above, how many honorable mention ribbons were awarded altogether? This is just a count up the bars sort of question. And the first honorable mention bar is a 4, plus a 2, plus a 5, plus a 1, plus a 1. And so we got answer choice. So this adds up to 13. We got answer choice D. Okay. In the figure above, point A is the center of the circle, and segments B, D, and CE are diameters. Which of the following statements is true? So let me go ahead and do my masterful drawing here. Diameter, by the way, means that it's going to cut right through this the perfect dead center of the circle, and also remember that half of the diameter is going to be the radius. All right, so it's telling us that this segment is 6, so we already know now, ooh, better handwriting, we already know now that the diameter equals 12, because there are 2 line segments here, each of length 6. All right, and then this little chord here that's subtended by these two, here let me pull out, I'm using new software now, that's subtended by these 2 lines that are diameters. That chord and this segment are going to be equal. All right, let's see. So now let's go ahead and do a process of elimination. They're asking which of the following statements are true. So CA equals, and let's see here, CA is this segment, this is our C, this is our A. CA is equal to 6, or the radius, that's the radius, so CA equals radius, which equals 6. And is 6 greater than 6? The answer is no. So answer choice A can't be it. And let's look at B now. So ED. ED is this segment right here. Maybe I should have just drawn out all the diagrams beforehand. So ED is the chord, which is equal to 4, and is 4 greater than 4? The answer is no. So this is not our correct answer. BA. Let's see, BA, here's our B. So BA is radius, which is equal to 6. And then we're asking ourselves, is 6 less than 4? The answer is no. This is good old process of elimination that we talked about in our first video. So beyond just knowing the math, sometimes it's helpful to know how to take the test, know the test kind of thing. And this process of elimination is a common technique. This is also radius, and is radius equal to 4? The answer is no. And so we can already circle answer choice E, but let's go ahead and just double check. ED is equal to the chord, and that's 4 right there. And is 4 equal to 4? Yes. So this is the correct answer right here. All right. So let's go ahead, go to the next page for number 3. And let me go ahead and do this. Take away my little green pointer. Oh, here we go. We have this construction here that they're defining. These problems are kind of crack me up. For positive integers A, B, and C, let this ABC stacked up Tetris style be defined by, and then they have this definition, and these kind of questions are testing really process of the good old order of operations, or PEMDAS, right? And these kind of questions also test out your knowledge of algebraic operations. And are you comfortable with taking a sort of semi-abstract definition that can come in pictorial format, like A star will equal 2A plus A squared or something. And in this case, we have this ABC Tetris block equaling this expression. So what is the value of, and then they go from the semi-abstract to the more concrete here, and they give us some actual values to put in, 5, 2, 6. And so we just follow the definition here. That 5 is an A, that 2 is a B, and that 6 is a C. So we're going to go, here's our, let me bring out my pointer again, here's 5 to the B minus, and now this is when it's a test of PEMDAS, minus, not just, I wouldn't just write 5. I would put it in parentheses just so that you can keep track and know that you need to multiply first. Don't go 5 squared on your calculator or in your head and then hit minus 5 and then go times 6. That would be going 5 squared minus 5 times 6, which is not following the definition. All right, so go ahead and keep things straight to yourself. More parentheses is better than less, as long as you're putting them in the right places. Plus the C, which is 6. All right, so we got a 25 minus a 30 plus a 6. And so then our answer is 1, and that's answer choice. Let's see A there. All right. So let me see. I wonder if I can just clear this screen. I'm testing out this new software here. Well, you know what? Let's just go to the next page. All right. So we're on number 4 now. So in the xy coordinate plane, what is the area of the square with opposite vertices at -2, 2, and 2, 2? So opposite vertices. What is that? Opposite vertices. Let's define this real quick. So vertices, let's for now just think of them as corners. So the vertices of this triangle would be at A, of triangle ABC would be at A, B, and C, the corners. And the vertices of a rectangle or square likewise would be at the corners. Okay, so when it says opposite vertices, they mean those corners that are opposite from one another, like in this fashion. They don't mean like if this were a rectangle A, B, C, D. Opposite vertices does not mean A to B. Okay, it would mean A hop across to C. Those are opposite vertices. All right, so let's go ahead and draw this XY coordinate plane. And let's go ahead and put in our tick marks. This will be our -2, this will be a +2, and this will be a +2. Here's a -2, and one of the vertices or corners is right there at -2, 2. -2, -2, sorry. And the other one is at +2, +2. So now we can fill in the rest of the shape here. And let me switch colors. Maybe this will make it easier to see. So we're going to fill in our shape like that. And we can now count how long this, oh actually it is a square, so we only have to count in one direction. We're going to go 1, 2, 3, 4, 4 tick marks. So this thing is 4 units across, and since it's a square, it's 4 high, which we could also validate visually. 1, 2, 3, 4, 5. If you really wanted to, you could burn too much time and prove this to yourself with a distance formula, but please don't. Let's just go. Now we're going to find the area of this square, and that's 4 times 4, which is 16, and that is going to be answer choice C. All right, and now let me take, I don't know, YouTubers, please let me know if you prefer me to write with the green pointer or not. So let's go ahead and look at number 5 here, and let me go ahead and switch back to my black ink. Oh, here we go. You already know where this is going when they start talking about children and their ages and stuff. Like, you're going to have to put them in order. So this is like a sort of classic word problem type of thing. The 4 children in the Speer family are Owen, Chad, Steph, and Daria. I already just make up. It's kind when the test writers go ahead and give you names of children with different first letter names. Owen, Chad, Steph, and Daria. Chad is neither the youngest nor the oldest. So let me just read it through. Daria is one of the 2 older children. Steph is the youngest child. Owen is often taken care of by his older brother and sister. Who is the oldest child? When you get these kind of problems, I want you to write little position holders. Like here's position 1, position 2, 3, 4, and figure out where each element goes. Sometimes it's going to be children, sometimes it's going to be integers, or sometimes it's going to be, whatever kind of heights of people, that they're going to come up with. But essentially it boils down to cardinal positioning. That's a fancy way of saying what order does stuff come in. All right, so then we start teasing out the clues. All right, so Chad is neither the youngest nor the oldest. So Chad cannot be in position 1 or position 4. This is youngest, and that's oldest. So Chad is going to occupy position 2 or position 3. We don't know yet. Daria is one of the 2 older children. So that's just position 3 and 4. One of the 2 older is either this blank or that blank. So we got 3 or 4 for Daria. And then Steph is the youngest child. So they came out and said, hey, she's in position 1. So let's go ahead and write her in right now. We know that for certain. Owen is often taken care of by his older brother and sister. He can't be in position 1, right? So position 1 is out. But he has an older brother and sister. So we have, here's a brother. Steph, we already have taken care of. And here's a sister. This means that Owen can't be in position 3 or 4 because they have to occupy those blanks in order to be older than he is. So we're going to go ahead and put Owen right there. We know now he has to occupy position 2 because he can't be in 3 or 4. So now look, we have Chad is in 2 or 3 and the sister is in 3 or 4. So the only way for this to work out, because since Chad can't be the oldest here, we have to put him here and Daria has to be here. So Daria is the oldest sibling, and that's going to be answer choice B. Okay. Number 6, if QR is parallel to PS in the figure above, what is the value of 2 multiplied by quantity x plus y? The SAT loves to test 2 parallel lines cut by a transversal. There are 2 parallel lines somewhere out there in an XY coordinate plane, and there's something cutting through both. They are quite clever at disguising the fact that they're testing this. So in this case, they're able to disguise the fact that they're testing this by drawing this parallelogram like this and not showing you that they're testing this concept. And they're giving you this y and then this x. And they're saying, hey, this is P, Q, R, S. But usually when you're taking the SAT and this concept comes up, feel free to draw lines like this and extend them past whatever diagram the test writers have given you. And then you could see, hey, the opposite angles are equal. So this x is equal to that x. That y is equal to this y. And as we know from our parallel lines cut by transversal rules, we know that has to be x, and that has to be x. This has to be y. Sorry, these letters are getting in the way. And this has to be y. And what do we know about supplemental angles, or angles that lie along a line? Well, we know that their sum has to be 180. Now don't jump right away and answer choice C. They've laid a little trap for you, and there's a seemingly wrong answer just waiting for you, because the question is actually asking what is 2 times x plus y. All right, and 2 times 180 is 360. And that's going to be answer choice E. Maybe we need to do a quick review of parallel lines cut by a transversal, just to make certain that this makes sense. So let's go ahead and draw. Pretend those are parallel, please. Well, let's pretend these are parallel. And we're going to cut it with a transversal. You know what? Take one more step back from even that. Imagine that out there in the void of infinity, there's a plane somewhere out in outer space, say, and there's a line in that plane. Now imagine you draw another line that's not parallel to this one. As long as that other line is not parallel to this one, it will inevitably, somewhere in the infinitude of space, cross this line. If they're parallel, they'll never touch. But if there's just the slightest deviation from parallel, eventually they're going to touch, okay? And when they do, something special happens. We have the creation of opposite angles, which are always equal. If they meet, and this happens to be, this figure's not drawn to scale, if this happens to be 20 degrees, we know always that this will be 20 degrees. They're equal when they face across from one another. Go ahead and visualize that in your head for a little bit until it makes a more intuitive sense. And then these angles will also be equal because they are also opposite one another. And then on top of that, anytime you have angles lying along a straight line, they add up to 180 degrees. 180 degrees is a half turn. And anytime you have all four angles like this, in this two lines crossing each other situation, the whole thing adds up to 360 degrees, or a full circle. Two parallel lines cut by a transversal is essentially this situation repeated twice. So look, here is an x and an x, just like here, x and x. You can pretend that this whole chunk of the graph doesn't exist yet. It's just these two lines here for now, let's say. I'll darken them. Let's just say it's those two lines, and the rest of this graph doesn't exist yet. Those two lines, those two angles are equal, and these two angles are equal. When we extend the situation and repeat this line over here, we have the exact same big X happening lower down in this visual thought experiment. And that's why these x's are equal. That's the actual reason. This is literally repeated in tessellation. We can have infinite parallel lines going on forever, and they all have the same x angle. I know the screen's getting messy, but I kind of get excited sometimes. And then these are all the y's. The x plus y's add up to 180, and 2x plus 2y, or 2 times x plus y, is going to be 360. Sometimes math teachers don't have time to explain all this. They just give you the rule and they don't say why. And that's why that's one of the reasons why I like doing these videos, actually, because then I get to go a little bit further into actually why this stuff is the way it is. All right, so this is all to say answer choice E. All right. I think I already said the answer choice earlier. I hope I did. 360 degrees, answer choice E. All right, let's go ahead and go on now to number 7. Oh, the company logo is gone from this page. Oh, I'm in trouble now. That's okay. So here's number 7. The average, or arithmetic mean, of 3 positive numbers x, y, and z is 12. Whenever they say that the average of these elements, x, y, z, or a, b, c, d, e, or whatever, is equal to some number, you can right away write an algebraic expression. So x plus y plus z, and then you divide that expression by the number of elements in your summation. That's what an average is, right? If you have the average of 10 people's scores, you're going to add up all their scores and then divide by 10, or the number of people there are. So we're going to divide that by 3, and they say that's equal to 12. Usually then, for the SAT, you find yourself having to multiply to find the summation of only those individual elements. All right, so x plus y plus z is equal to 36, because 12 times 3 is 36. So when the greatest of these numbers is subtracted from the sum of the other two, the result is 4. And then they give us a nice key to unlocking the problem. They tell us which one is the greatest of x, y, and z, because they say x is less than y is less than z. So that means z is the greatest of those elements. So which of the following pairs of equations could correctly express the information above? All right, let's backtrack a little bit. When the greatest of these numbers is subtracted from the sum of the other two. So sum of the other two is x plus y, and then you subtract the greatest, and then the result, they say, is 4. So we need to look for these two equations amongst their answer choices. What I do is I immediately eliminate C and D because they're saying x plus y plus z is equal to 24, and this already lets me know those can't be it. And then I look at that second of the pair of equations on each answer choice, and I see answer choice A has an x plus y minus z equals 4 paired with this expression, x plus y plus z equals 36, and so our answer is A. Alright, so let me see here. Let's see if I know how to clear the whole page from this. Yes! Alright, excellent. So answer choice A for number 7. Now let's go ahead and go to number 8 here. If x and y are positive integers and 3 to the 2x multiplied by 3 to the 2y equals 81, what is the value of x plus y? Sorry for my bad handwriting there. So whenever you're multiplying like bases, there's a rule we have, which is that you add their exponents. So let's backtrack a little. So remember those rules like a to the x multiplied by a to the y is equal to a to the x plus y. So that's one of the rules for exponents, and a to the x all raised to the y power is going to be a to the x multiplied by y. A lot of times people get those two mixed up, so you want to really keep them separate in your minds. And then you might remember a to the x divided by a to the y is equal to the a to the x minus y. Let's see, what else should I go over for now? One thing to really keep in mind is this only works when two conditions are met. There have to be like bases. That's condition 1, like bases. Now sometimes some things can be like bases, but they don't look like bases. You can do algebraic manipulations to make them like bases. But anyway, so it has to be a situation like we have here, 3 to the 2x times 3 to the 2y. If it were 3 to the 2x times 4 to the 2y, the bases are not like, and we can't apply this rule here. All right. The other thing is the bases must be multiplied. If they're not multiplied, you can't apply any of these rules. You can't apply this rule or that rule because division is actually multiplication. It's actually saying a to the x times 1 over a to the y. This is just sort of a shorthand way we've come up with so we don't have to write things out this way. But anyways, for this first rule I've written, or this third rule I've written to apply, the bases must be multiplied together. So if this problem said 3 to the 2x plus 3 to the 2y, we can't do these rules in the way that I'm about to show you. Or if it were a minus, it's not going to work. Okay, but we're able to apply this first rule here, and so we have 3 to the 2x plus 2y equals 81. Now, can you think of a power of 3 that equals 81? You might need to play with your calculator, but if you, for instance, let's just for now, just go, well, 3 squared is equal to what? 9, right? 3 cubed, 27. This increases really, really fast, right? And now let's go ahead and go 3 to the 4th. And you'll see that we have, if you don't remember it off the top of your head, you can play with your calculator a little bit, and you'll have 3 to the 4th equals 81. And now we know we can set this equal to that. And so we have a 2x plus 2y equals 4. And now they want to know x plus y. In order to make the left side of this equation look like x plus y, we need to divide by 2. And then we got x plus y equals 2. And let's see, which answer? That's answer choice B. I'm always nervous I'll forget to say the answer choice. I've done that a few times. start talking a whole bunch about a problem and talking about all these different rules and stuff, and then all of a sudden I go, oh yeah, I never actually answered the question. Never answered the question. I'm debating with myself now if I want to turn this into a full-blown review of the laws of exponents. Maybe that'll make this video a touch long. My videos sometimes get kind of too long, but we have the oh, you know what? On our website, we have a sheet. I think it's a free download. We have a sheet that has all the laws of exponents in nice format with examples and with suggestions on how to learn them. So go ahead and go to ivyscholastic.com and go to the resources section. And it's on there. You can do a search on the page for exponents or something like that, and you'll find it on there. Okay, so let's see. What number? Okay, I'm on number 9. It's hard to do these videos sometimes because I have like the book here and the screen up here, so I get disoriented. Anyways, let's go on to number 9 here. So, the figure above shows a graph of y equals f of x from x equals -8 to x equals +8. Now, for what value of x in this interval does the function f attain its maximum value? One thing the SAT writers sometimes, let's just say it this way, it's sometimes not clear what's drawn to scale on the SAT and what is drawn to scale. So let me help clear that up. Whenever you're dealing with number lines, let's see, number lines, or Cartesian planes, like this one. Cartesian plane just means an XY graph. So let's just say XY graph. Whenever you're dealing with those things, they are drawn to scale. It's conceivable that one day the test writers would create a question in which they're not, but I've never seen it done, ever. If it were done, it would have that, note, figure not drawn to scale. Drawn to scale. It will have that warning, but I've never seen them do that with number lines or Cartesian planes. However, for geometric figures, so geometric figures, there's often the warning that the figure is not drawn to scale. So things like the circle that we dealt with earlier with the, it was like an hourglass actually, with the hourglass inside, the Black Widow geometric figure. Is not necessarily drawn to scale. But here's what's kind of funny. To be honest with you, a lot of them are actually drawn to scale anyway. And so you can sometimes, but please don't rely on this method, but if you really just can't solve a problem and you've already, a geometric figure problem, and you've eliminated at least one answer choice or two, but don't do this if you really just are stumped by the problem. But if you could at least for sure eliminated one answer choice, you might be able to kind of use your thumb to sort of eyeball the figure and find a missing angle or something. It is not at all a foolproof method, because I can think of, they sometimes very much have figures wildly drawn out of scale. Here's one example. This question stumps most students. Page 401, section 3, test 1, number 19. That figure not drawn to scale pyramid is like really not drawn to scale. So, where's number 17? Okay, I'll stop there. Anyways, let's actually answer this question. Number 9. Here we have this noodle. Woo! And it's saying, when does this function f attain its maximum value? F of x is kind of like saying y. So when they ask for a maximum value, they're asking for a maximum y value. And that's going to be right there. And the reason why I went and talked so long about figure not drawn to scale is because this is a Cartesian graph. It is drawn to scale, and you can just count the tick marks. Let's see, how many are there? 1, 2, 3, 4. 1, 2, 3, 4. That 4 lines up with the maximum y value of this noodle graph, and so 4 is our answer. Functions are like a machine. And imagine this little machine with a crank that someone turns, and you put in x values and then out pop f of x values or y values. So when you put in a 4 into the machine that is the function, and the function is algebraic, the gears of the function are algebraic manipulations. They're addition, subtraction, raising things to powers, they're division, whatever algebraic manipulation there is, logarithmic, which you won't see on the SAT, but logarithmic expressions. You put in the x value, all this stuff happens to it, and then out comes some y value. All right, and we don't have to know what the y value is. We just see that this height of the noodle is higher than all the other y values of the noodle. All right, let's go. Oh, let me actually make sure. Here I go again. That's answer choice B for 4. All right, and now let's go ahead and go on to number 10. If k is equal to x over 3, my pen is worn down to almost nothing. I better replace the little chunk of lead at the tip. And x does not equal 0. What does 3x equal in terms of x? Sorry, equal in terms of k. 3x in terms of k. All right, let me think. You know what? I want to show you 2 ways of doing this. I'm trying to think of what's you know what? Hey, okay, so the first way is to recognize, hey, if I just multiply a 9 straight across this expression, boom, I'm going to get 9x over 3, which, what's 9 divided by 3 is 3. That turns into 3x. And so there's 3x. This thing that the SAT says, in terms of k, that's another way of saying, hey, when one side of the equation looks like this, what does that side look like? Well, it looks like 9k. And so that is going to be answer choice B. Another way of doing it, because sometimes students ask me, but how would you know to do that when you're actually on the test? Let's say you didn't have that you didn't immediately say, hey, if I multiply by 9, I'll get it to look like this. That's okay. You start to do some algebraic manipulations to get to know the problem, you know. So here we got k equals x over 3. I know that they want 3x or something having to do with x in terms of k. And so I'm going to isolate that x all by itself in this equation. So I'll multiply both sides here by 3. And I'll have 3k equals x. And I say, all right, it still doesn't look like 3x. So how do I make x look like 3x? Well, I multiply it by 3. So we multiply that by 3. And whatever I do to one side of the equation, I have to do to the other side of the equation. And now I have my 9k equals, instead of writing x3, I'll go ahead and reverse the order, 3x. And that leads me back to answer choice B. Number 11. The cube has 2 faces painted black and the remaining faces painted white. The total area of the white faces is 64 square inches. What is the volume of the cube in cubic inches? Let's go ahead and draw. Even if you're not good at drawing, it's okay to just sketch things roughly on your SAT booklet. So I'll just pick 2 faces to be painted black. So I'll go ahead and paint this top. Imagine the very top of this cube and the very bottom of this cube are painted black. Since it's a cube, we know that all the sides are equal in length. So we'll just make up a variable for those sides. I'll just say it's L for length. And just keep in mind that this and this and this, all of these sides are all equal to L. So it's saying the total area of the white faces is 64. So that means this face in the back, which is 1 face, face in the front, which is 2 faces, face on the left, 3 faces, and face on the right, 4 faces. So we have 4 faces, has an area of, what is it now, 64? And so that L times L in a square is equal to area. So remember, here's like a little just chunk of the back here. To get the area, we're going to go L times L, or L squared. And there are 4 faces, so we do that 4 times, or 4 times L squared. All right, so let's go ahead and divide both sides by 4. that's going to equal 16. If you didn't do that in your head, that's fine. Just go ahead and pull out your calculator. 64 divided by 4, you got 16. It's always good to double check your calculations when you're under pressure and you're actually taking the test. So we have L squared equals 16. We're going to square root both sides, and we'll find that L equals 4. We're not done. So we actually are being asked the volume of the cube. One thing I often tell my students is to go ahead and underline the actual part of the question. Underline the actual part of the SAT problem that is asking you the question. So where you see that question mark appear. So it'll say, what is the volume of the cube? So let's go ahead and review. If the area of a square is L times L, and we extended this out by some height, the volume is going to be essentially a measurement of how much space all the stuff inside takes up, or you could think of it as the air inside this box that's in the shape of a cube. That extra dimension of height is also equal to L in a cube, and so you're just going to go L times L times L, or L cubed. So 4 cubed is equal to 64. And again, if you want to double check, go ahead and go 4 cubed on your calculator. And it's 64. And that's going to be answer choice A. Think about this a little bit. The area here is L squared, and by multiplying by the L coming out of our page / screen towards our faces, we're like taking in all the cross sections of that area all the way out L high, or height H high, whatever number we're dealing with. And that's why it's like an L cubed. That concept actually returns in calculus in a more sort of complex form when you're dealing with integrals. You're going to take things like the area beneath a curve, and you'll start to conceptualize of it as taking a whole bunch of little cross sections of something to approximate the area, making infinitely more precise approximations, and then taking a limit or something like that. So we can actually use the SAT to kind of prepare us for more sophisticated math, even with the simplest seeming problems like volume of a cube. All right, number 12. The letters V, W, X, and Y represent numbers as shown on the number line above. Which of the following expressions has the least value? So this is when we're going to take advantage again of the fact that number lines are drawn to scale on the SAT. And if they ever come out with a question that's not, it'll advertise it. But like I said, I've never seen them have a number line not drawn to scale. -1. The point of that is we can just fill in what looks to be the actual values of these numbers. And even if they aren't exact, I'll just say that's -3/4. This is -1/2. There's no value there. This will be a +1/4. This will be 3/4. And I did that because I'm assuming that each interval is a quarter and that it's to scale, so it'll always be a quarter. So a quarter plus a quarter is 50 cents, right? Half of a dollar. So a quarter and a quarter, we get to half. Another quarter is 3/4, and another quarter gets us a whole dollar. And if we're going into the debt side of the number line here, here's two. You owe 2 quarters. 2 quarters. Now you owe you owe 50 cents, or -1/2 of a dollar. Another quarter gets us -3/4, and then another quarter gets us a whole in debt $1. All right. So now it's process of elimination again. So here's answer choice. Let's just A, B, C, D, E. I often start with answer choice C and work my way up or down if it looks like things are ordered in ascending order. But just by taking a glance at this, I don't feel like I can assume that. So I'm not going to do that this time. I'm going to just, instead of starting with answer choice C and adjusting up and down, I'm going to just go ahead and start with A. And we have a V plus Y. So we have V is -3/4 plus Y, which is 3/4. Probably help to have my pointer. Y is 3/4, and that equals 0. And remember, if we underline the part of the problem that is actually asking us the question, we know we're looking for the least value. So far, we keep 0 in mind. V plus x is equal to, well, -3 plus -1, -2/4, which is a -1/2. That's, let me make that negative sign more obvious. That is smaller than 0, so we're going to go ahead and cancel out a. Let's look at c. W plus x, and that's -1/2 plus a +4th, and if you can make the bases like by multiplying the numerator and denominator by 2, so -2/4 plus 1/4 is equal to -1/4. Now what's the lesser of the two in value? -1/2 or -1/4? It's going to be -1/2. And if that doesn't make sense right away, just think, what is being in more debt? Owing a quarter or owing 2 quarters or 50 cents? So 50 cents is being in more debt, so it's a less value than expression C. D is V minus W. So that's -3/4 minus, now be careful, -1/2, which is the same as -3/4 plus, let's go ahead and multiply numerator and denominator by 2 so that we can get the same denominators, and we can just add right across, plus 2/4, and then we're going to have ourselves -1/4. That's the same as C, and so we can go ahead and cancel out, eliminate that answer choice, and then we got a y minus x, which is, we're looking up at our approximations here, 3/4 minus 1/4. The denominators already look alike, so this is equal to 2/4 or half, a +1/2. And so that answer choice is eliminated, and we're left with answer choice B, as in boy, for 12. Number 13. All right, the number n is added to the list above. If n is an integer, which of the following could be the median of the new list of 7 numbers? The fact that it's an integer means that it has to be a positive or negative whole number. So like a -10 or a 3 or a 300. All those are integers. There's not going to be any decimal expression like that, or 3 1/3. So this integer actually is helps us eliminate one of the fact that it has to be an integer is going to quickly help us eliminate one of these answer choices. So okay, n is an integer. Which of the following could be the median of the new list of 7 numbers? So let's go ahead and draw out our list of numbers. Write out our list of numbers: 3, 4, 6, 7, 10, and 12. Recall that the way to find median is it's essentially a measure of central tendency. It's one of our measures of central tendency, along with mean and mode. So we just start lopping off the ends until we come to a middle point on our list of numbers. So we can take off 3 and 12. We'll eliminate 4 and 10. And look at this. We're left with 2. We can't lop those off because there's like an empty space in between. So what do you do when you have these two values appear? Well, you add them together. Well, you take their average. So you add them together, divide by 2. And this is going to get us 6 1/2. All right, and now anytime, I want to go ahead and say this. 1, 2, 3, 4, 5, 6. There are 6 numbers. That's an even list, even numbered list. With even numbered list, the median always has to end up being the division of 2 numbers. All right, but now we're going to add a number, n, and that n could be any integer. Once we've added that number, it's going to become an odd numbered list. And odd numbered lists never have an averaging of 2 numbers together. So you can prove that with your fingers. You know, the median of our fingers ends up being our middle finger. We have an odd number of fingers. And so it's the same kind of thing happening here. Now we're going to have an odd list. Let's say n is at the front of the list or on the bottom. Let's say n is 1. So we got a 1, 3, 4, 6, 7, 10, and 12. Let's go ahead and switch colors here. We start lopping off the ends. and we come to our middle. So that already proves proposition 1. It can be a 6. Let's say that our number's at the top of the list or end of the list. So list is 3, 4, 6, 7, 10, and 12, and then let's just add 13 on top. Start lopping off the ends, and now we have 7. That approves assertion number 3 there. Wow, my pen is really gone down to that. Luckily I have a replacement. I did not realize this. And so now let's look at assertion number 2. It says 6.5, which is the original median. But whatever we add is an integer. Let's add 1 to the middle of the list. 3, 4, 6. Let's say n is 6. It can't be 6.5. That's critical. It's an integer. And then 7, 10, and 12. Start lopping off the ends again. And because it's an odd-numbered list, we're never going to have to take the average of 2 numbers. It'll always be just a single number, and that number has to be an integer, so it can never be an expression like 6.5 or 6.5. So we're left with just 1 and 3. Let's see, which is answer choice D. All right, we're almost done with this section. Here we got 3 more questions. Let's see if my bamboo pad pen can survive all the way until then. Okay, so, oh look, we have, I guess it's a tennis ball. Or sorry, not tennis ball, baseball. So it says this is going to be color 1, color 2, and then color 1 again. It just repeats. As shown above, a certain design is to be painted using 2 different colors. They just say a certain design. They won't say what kind of design it is. If 5 different colors are available for the design, how many differently painted designs are possible? All right, write out those blanks like I showed you earlier. And the number of possibilities is going to be simply whatever goes in those blanks, and those blanks represent how many possible colors are in each one of these slots. So here's, region 1 of this ball, or certain design, as they say. Region 2 is going to go there. How many possible colors there are for region 2? And region 1, again, the third region, which is a repeat of region 1's color, is going to go there. We have 5 different colors. That means there are 5 possible colors for region 1. And now they have to be different colors. So a common mistake is going to be to write in a 5 there, but you can't. You can't repeat colors. There's only 4 possible colors left now for this region of our design. And look, how many possible choices are there for the third region if you have to repeat, have to copy whatever color goes here? It's not 5, it's not 4, it's not 3, it's only 1. You're forced to use whatever. So if this is blue over here, this has to be blue, and this has to be something different like red, all right, or yellow or green or whatever. So you only have 1 possibility there, and so we're left with 5 times 4 times 1, which equals 20. And that's answer choice B. All right, number 15. If the length of a rectangle is increased by 30% and the width of the same rectangle is decreased by 30%, what is the effect on the area of the rectangle? Don't write C. Don't answer C. Let's actually, don't take it for granted. Actually work out the problem. So let's draw this original rectangle. Now let's go ahead and specify that as the length. This is the width. And you know what? I'm going to show you 2 different ways of doing this. I'm going to show you a little bit slower but formal way first, and then I'm going to show you a sort of quick way. So the area of this thing is L times W, right? L times W is our original area. But now we're making changes. We're going to increase the length and decrease the width. And they tell us by how much. It's going to be length plus 30% of the length, right? It's increased. This is the algebraic expression for increase by 30%. And then the width is going to decrease by 30%. All right, let me just double check that that's what's given. Yeah, let's see. Length is increased by 30% and width of the same is decreased by 30. So what's the area of this new rectangle? Well, it's going to be length times width again. But the length is now L plus 0.3 L, and the width is W minus 0.3 W. So the area, we'll write out over here, L plus 0.3 L multiplied by W minus 0.3 W. All right, so let's work that through. So it's first outer, which cancels out. First outer, inner. The outer and the inner cancel out, and then last. So be careful. 0.3 times 0.3 is not equal to 0.9. It's equal to 0.09. Go ahead and you can prove that to yourself. 0.3 times 0.3, we have a 0.09 right there. So I think one reason why people miss this a lot is they're rushing and they forget this 0.09 LW. Look at this algebraic expression. LW is original area minus what's 0.09 in percentage, 9%. And is it increasing or decreasing? It's a decrease of 9% in the area. And let's look at our answer choices here. It is decreased by 9% as answer choice E. Is that off the screen? Here, let me just write it up here. Answer choice E. So that's the little bit slower way of doing it. Let's show you a quicker way. I guess I'll draw it right in this upper hand corner. So original area is LW. A 30% increase in length is the same thing as 1.3 L, and a 30% decrease in width is the same thing as 1 minus 0.3, which is 0.7 W. And now just multiply the two together. So if you want, just go right to your calculator, go 1.3 times 0.7, and we got a 0.91 LW. Well, what is the change from LW to 0.91 LW? Well, it's a decrease of 0.09 or 9%, and then we can circle E. Last one, number 16. All right, this is a part of the video where it would be kind of funny if I just did all of this and I forgot to hit record on this video this whole time, and I'm just talking at my screen. Okay, oh my gosh, I hope that didn't actually happen. So n of t equals t squared over 2 minus 20t plus some constant k. What does that mean, a constant k? That means that unlike a variable, the t, it does not change. So the variable can change. We can plug in new numbers into the function, which then get plugged right into where those variables are. Though variable, it varies, those can vary, but constants don't. It's just that it's an unknown number. They don't give us that number. That's what that means. So a quick repeat review of functions is they're like machines. You can imagine an input nozzle there, or a funnel, and an output. And I like to imagine a crank, like you're going to crank a number in. So you put in x values, and you get out f of x values. In this case, it's t values for time. It's a common variable for time. And what's going to come out is n of t. N is often used for number, and we're dealing with number of bees. So there was a 100-day period when the number of bees in a certain hive could be modeled by the function n above. So that's what's going on. And inside here are, like we said earlier, algebraic, and my pen is dying, operations. Oh, come on, pen, survive for one more question. Algebraic operations. Okay, modeled by the function. In the function, k is a constant, and n of t represents the number of bees on day number t. So you tell us the day, and we tell you how many bees there are. That's what the function is. We put in the time, and out come number of bees. Bees, there you go. All right, but it's constrained from 0 to 99. Okay, so on what number day was the number of bees in the hive the same as it was on day number 10? Well, to know how many bees there were on day number 10, we need to put in a 10 into the function box to get out the number of bees. So n of 10 is equal to 10 squared over 2 minus 20 times 10 plus that unknown constant, which doesn't change. We don't have to plug in a 10 for that. That's just some unchanging value. So this is 100 divided by 2, which is 50, minus 200 plus k. We'll go ahead and simplify that to negative 150 plus k. All right, so this is how many b's there are on day number 10. Negative 150 plus that unknown value. We're going to guess that that value is at least 150, right? Because otherwise there would be negative b's, which would only exist in a science fiction novel. There's like antimatter b's or something. Anyways, I'm getting off track. So this is how many b's there are on day 10 or n of 10. Now it's wanting to know, well, how many b's are there at what other time t does this whole expression, or which is number of b's, equal to that? So we're going to go negative 150 plus k equals this whole thing, equals, hey, you know, it equals number of b's. When does the number of b's at that other time t equal that? Well, now we need to set this in. So t squared over 2 minus 20t plus k. Let's go ahead and get this whole side of the equation equal to 0. So we're going to add 150 minus k to both sides. I'll put the minus k right here because those are going to cancel out. Good. Now that mystery value's gone. We don't have to worry about it anymore. So we have 0. All this here gets equal to 0. 0 equals t squared over 2 minus 20t plus 150. The k's have canceled out. I don't like that half sitting there. It makes factoring hard. If you wanted to, you can now. If you wanted to, you could you could go and do quadratic equation if you wanted to. But I want to actually just factor this normally. So I'm going to multiply both sides of this expression by 2. 2 times 0 is still 0. Now this is looking a lot nicer to me. T squared minus 40t plus 300. And now we're going to factor. And now this is when students ask me, but how do you know easily how to factor this? Well, 2 ways. One, you could just go right to the quadratic equation and plug in a equals leading coefficient 1, b equals negative 40, and c equals 300. And I'll go over that, but that takes too much time. Check it out. We know that the time has to equal 10 at one of the times in which this expression equals this other part of the expression. So we know that one of the factors is going to be 10. So now we go, well, what's 300 divided by 10? And that's going to give us a 30. And these are positive time values. We're dealing with time. And this is why they give us this little constraint. T is in between 0 and 99. In other words, t is positive. So that means these have to be negative signs. And so the answer is t equals 10, as we already knew. And it's the same again at 30. So that's answer choice B. All right, but let's go ahead and look at this way of doing things. In case, let's say that you forgot about this part of the problem. Let's say that you weren't able to factor this because these are they're big numbers for just factoring using the typical factoring methods. And you're going, hey, what do I do? Well, if you really get stuck, remember your quadratic formula. So the A is, let's see, we have A of 1, a B of negative 40, and a C of 300. And my pen is not there. Almost there. Negative B, our quadratic formula is negative B plus or minus the square root of B squared minus 4AC all over 2A. And then we just start plugging stuff in. Negative 40 is positive 40. Plus or minus the square root of B squared. Negative 40 squared is 1600. You can double check on your calculator. Minus 4 times 1 times 300, which is 1200. Another thing, it's nothing wrong with double checking on the calculator if it helps you avoid errors on the SAT. All divided by 2. So we want to have a 40 plus or minus the square root of 400, which is 20, all over 2. And then we got a 40 plus or minus 20 all over 2, which is the same as 20 plus or minus 10. 20 plus 10 is 30. 20 minus 10 is 10. And so these are your two time values. 10 they already gave you, and so it's going to be 30, answer choice B. All right, so we've now done all the math sections of test 1 of the Blue Book, and good luck on your SAT and your studies in general.